Hey guys, this is Eddie the Magic Monk. Today we're going to start proving some trigonometric identities. In particular, these are all Pythagorean identities because they all come from the Pythagoras theorem. So how do we prove this? Well, before we start proving it, I just want to write out some of the formulas that you should already understand. So we have the basic trigonometric ratios. Hopefully you understand this already. Sine theta is equal to opposite over hypotenuse and so on. Then we have the reciprocal trigonometric ratios, which are secant theta equals 1 over cos theta, cosecant theta equals 1 over sine theta, and cotangent theta equals 1 over tan theta. So basically you just do 1 divided by the trigonometric ratio, then you get the reciprocal ratio. Okay, so you obviously also need to know the Pythagoras theorem, which is a squared plus b squared equals c squared. So if you don't understand any of these ratios, any of these equations, you probably have to go back to some of my other trigonometry tutorials. Okay, so once you're okay with these ratios, the first thing we need to then show you is that tan theta is equal to sine theta over cosine theta. Right, so why is that the case? Well, if you have a look at this equation here, we got tan theta equals opposite over adjacent. Now, sine theta is equal to opposite over hypotenuse. So if I rearrange this equation and multiply by h on both sides, then I will get h sine theta equals the opposite. So, and then if I do the same thing with this equation, I will get h times cos theta equals the adjacent. So if I then replace both O and A with these two expressions, right, if I put O and A there, then I will get h sine theta over h cos theta. Okay, now h divided by h is equal to 1, so I can change that to 1. So therefore I have tan theta equals sine theta over cos theta. Okay, done. So I have proven one more identity for you guys. Tan theta equals sine theta over cos theta. Regardless of what theta is, this equation will always work. Okay, now we can go ahead and try to prove the first one. Sine squared theta plus cos squared theta equals 1. So the first thing we do is we draw a right angle triangle. Right, draw a right angle triangle with A, B, and C. Now, C has to be the longest side. A and B can be whichever one, it doesn't matter. And at the same time, I'm also going to draw theta on this right angle triangle. And I'm going to label the sides as opposite, adjacent, hypotenuse. Now, notice how A and B can be reversed. So you could say the A is opposite or the B is adjacent and so on. It doesn't matter how you do it. Okay, now the next step is to use the Pythagoras theorem. So a squared plus b squared equals c squared. And now what I'm going to do is I'm going to divide by c squared on both sides of the equal sign, which will make the equation stay the same because we're doing the same thing on both sides. So I'm going to divide both sides by c squared. Then I will get 1 on the right hand side. On the left hand side I will get a squared over c squared plus b squared over c squared. because we can separate a fraction into two fractions as long as the denominators are the same. Alright, so an example of that could be 5 over 3 plus 6 over 3 is 11 over 3. Right, I've separated 11 over 3 into two fractions. So that's what's happened here. And then, so this is not part of the proof, this is just an example. Okay, and then what I'm going to do is use the index law where we have a over b to the power of c is a to the power of c over b to the power of c. That's just one of the index laws. Not part of this proof, just giving you an example. So then I can rewrite this as a over c squared plus b over c squared equals 1. Okay, now what does a over c equal? Well, if you have a look, a over c is the same as a over h in my triangle. So then I can put a over h squared plus b over c, so that's o over h squared equals 1. Now what does a over h equal to? Well, if you remember the three ratios, a over h equals cosine theta. So I have cosine theta squared plus sine theta squared, right, because sine theta equals o over h equals 1. Now cos theta squared is rewritten as cos square theta, and sine theta squared is rewritten as sine square theta equals 1. This is just a convention that people use so that people don't get confused between sine theta squared and sine theta squared. Right, it's just easier. So these two are different. They're different. So yeah, this way, if you write the squared here, people know that you are squaring the whole cos theta instead of just the theta itself. Okay, so that is the proof of the first identity. Let's now try and prove the second one, which is tan squared theta plus 1 equals secant squared theta. So how do we prove that? Well, from the first identity, cos squared theta plus sine squared theta equals 1. What I'm going to do now is I'm going to divide both sides by cosine squared theta. So what I'm going to do is I'm going to go cos squared theta divided by cos squared theta plus sine squared theta divided by cos squared theta equals 1 divided by cos squared theta. So I'm dividing both sides by cos squared theta. So I'm going to now convert this notation back into the index, using the index laws, go back into one fraction with the squared on the outside. So I have cos theta over cos theta squared plus sine theta over cos theta squared equals 1 over cos theta squared. Okay, remember the index law that we talked about over here, right? A over b to the power of c equals a to the power of c over b to the power of c. So I'm putting the squared on the outside of the bracket. Okay, now cos squared theta over cos squared theta, that's just 1 squared. So I can just write 1 plus Sine theta over cos theta. That looks familiar. Where is that? Well, that is this equation. Tan theta equals sine theta over cos theta. So I can put tan theta inside of the bracket squared equals 1 over cos theta. That also looks familiar over here. 1 over cos theta is secant theta. So I'm going to put secant theta squared. And then rewriting the notation from the squared on the outside to writing it as tan square theta. So I get 1 plus tan square theta equals secant square theta. So that proves the second identity. So we now can try and prove the third one. How do we do that? So that's number 2 done. Let's try number 3. So number 3 also comes from number 1, sine square theta plus cos square theta equals 1. Now what I'm going to do now is, instead of dividing by cos square theta on both sides, I'm going to divide by sine square theta on both sides. So sine square theta and then I'm going to change it into the other index notation. So sine theta over sine theta squared plus cos theta over sine theta squared equals 1 over sine theta squared. Alright, putting the terms inside the bracket. And then what I'm going to do is I'm going to change sine theta over sine theta and turn it into 1. 1 squared is just 1. Plus cosine over sine. What's cosine theta over sine theta? Well, tan theta is equal to sine theta over cos theta. And then if we reverse it, so if we make it cos theta over sine theta, then we've turned the right hand side upside down, so we have to do the same to the left hand side. So I get 1 over tan theta. And if you look at what 1 over tan theta equals, 1 over tan theta equals cot theta, cotangent theta. So this also equals cotangent theta equals cos theta over sine theta. So I can rewrite this as cotangent theta squared equals 1 over sine theta is equal to cosec theta. So cosecant theta squared. And then I can rewrite this as 1 plus cotangent square theta equals cosecant square theta. So that is the third trigonometric identity that we have proven today. 1 plus cotangent square theta equals cosecant square theta. Okay, thanks for watching guys. See you next time.